For decades, Voyager 1 has been traveling farther from Earth than any other human-made object in history. Long after completing its mission to the outer planets, it continued its lonely journey into interstellar space, carrying humanity's curiosity far beyond the edge of our solar system. Most spacecraft eventually fall silent. Voyager 1 refused. In late 2023, something unexpected happened. Engineers on Earth noticed that the spacecraft was still responding to commands, but the information it transmitted no longer made sense. Instead of clear engineering data, strange, unreadable signals filled the communication stream. At first, many feared the mission had finally reached its end. After nearly half a century in the harsh environment of space, every onboard computer, circuit, and instrument had endured conditions no engineer expected them to survive. Cosmic radiation, extreme temperatures, and the passage of time had slowly worn down the spacecraft's aging systems. Yet Voyager was still alive. The challenge was extraordinary. Because of the enormous distance between Earth and Voyager 1, every command required many hours to reach the spacecraft, and every response took just as long to return. Solving even a simple problem demanded incredible patience and precision. NASA engineers carefully examined every bit of incoming data. Eventually, they traced the problem to damaged memory used by one of Voyager's onboard systems. Instead of giving up, the engineering team created an entirely new software solution, sending instructions across billions of kilometers to move important code into healthy sections of memory. It was one of the most remarkable remote repairs ever attempted. Days later, the waiting ended. Slowly, the spacecraft began sending understandable information once again. First came engineering data confirming that its essential systems were functioning. Then scientific instruments gradually returned to operation, one after another. Voyager had survived. But fixing the spacecraft was only the beginning. As fresh scientific measurements arrived, researchers once again turned their attention to the strange environment beyond the heliosphere, the enormous bubble formed by the Sun's magnetic field and solar wind. For generations, many imagined the space beyond this boundary as a quiet, nearly empty region. Voyager revealed something completely different. The spacecraft detected changing particle densities, shifting magnetic fields, and plasma waves moving through the thin gas between the stars. Rather than silent emptiness, interstellar space proved to be an active environment shaped by invisible forces stretching across vast distances. Each new observation added another piece to a puzzle that no telescope could solve from Earth. Voyager wasn't simply looking into interstellar space. It was traveling through it. Scientists realized that the region beyond our solar system contains changing magnetic structures and energetic particles that interact in ways still not fully understood. These discoveries are helping researchers understand how our solar system moves through the Milky Way and how stars influence the space around them. Even more importantly, Voyager is providing direct measurements from a place humanity has never explored before. Every signal carries information that cannot be collected any other way. Today, the spacecraft continues drifting farther into the galaxy. Its power supply slowly decreases each year, and mission controllers carefully manage every remaining watt of electricity to keep its most valuable instruments alive. No one knows exactly how much longer Voyager will continue transmitting. But while its signal still reaches Earth, it remains humanity's most distant explorer, crossing a frontier that no other spacecraft has yet matched. And what Voyager discovers next may reshape our understanding of the galaxy once again. Voyager 1 has now traveled so far from Earth that it is exploring a region no human spacecraft had ever reached before. Every signal it sends home offers a rare glimpse into the environment between the stars, a place once thought to be almost completely empty. Instead, Voyager has revealed a far more complex picture. Its instruments continue measuring changes in plasma, magnetic fields, and energetic particles. These observations show that interstellar space is constantly changing, shaped by powerful forces that stretch across enormous distances. Scientists now believe the space beyond our solar system contains invisible structures that guide the movement of charged particles throughout the galaxy. Rather than being uniform, this region appears to contain areas with different densities, temperatures, and magnetic conditions. As Voyager travels farther, it occasionally enters new regions where the surrounding environment changes noticeably. Each transition helps researchers build a better understanding of our local galactic neighborhood. Another important discovery involves plasma waves. Although space cannot carry sound the way Earth's atmosphere does, charged particles can create wave-like vibrations that scientific instruments are able to detect. Voyager has measured these plasma waves multiple times, allowing astronomers to estimate the density of matter surrounding the spacecraft. These measurements have become one of the best tools available for studying the interstellar medium. Researchers are also comparing Voyager's data with observations from newer space missions to create the first detailed maps of the region surrounding our solar system. The goal is ambitious. Scientists hope to understand how magnetic fields, cosmic rays, and clouds of gas interact over vast distances. This knowledge could prove valuable for future spacecraft designed to travel beyond the heliosphere. Long-distance exploration will require a much deeper understanding of radiation, plasma, and magnetic environments than we possess today. Voyager is providing the foundation for that future. Its discoveries are helping engineers prepare for missions that may one day travel even farther. Perhaps one day, spacecraft carrying advanced propulsion systems will follow Voyager's path into interstellar space. When that happens, they will already know far more about the journey because Voyager traveled there first. What makes this achievement even more remarkable is the spacecraft itself. Built during the 1970s, Voyager operates with technology that is tiny compared to modern computers. Yet its instruments continue collecting information that no newer spacecraft can currently obtain. Its mission has lasted far beyond anyone's original expectations. Every additional day of operation is another opportunity for discovery. Eventually, Voyager's power source will become too weak to operate its remaining instruments. Its final transmission will arrive on Earth after traveling for many hours across interstellar space. Mission controllers will know that the spacecraft has completed one of the greatest exploration missions in human history. But Voyager's journey will not end. Even after its radio falls silent, it will continue circling the center of the Milky Way for millions of years, carrying the famous Golden Record, a time capsule containing sounds, music, greetings, and images from Earth. Long after humanity has changed in ways we cannot imagine, Voyager will remain a silent messenger traveling between the stars. Its greatest legacy is not simply the data it has collected. It is the reminder that exploration never truly ends. Every answer leads to another question. Every frontier reveals another horizon. And somewhere ahead, in the endless darkness beyond our solar system, Voyager 1 continues its historic voyage, showing us that the universe is far richer, more dynamic, and more mysterious than we ever imagined.